Let me ask you something. If I told you a new AI model just destroyed every other model on a major benchmark, scored higher than anything released before it, would you trust it to write your medical report? Help you navigate a legal dispute? Run your business decisions? Probably not automatically. And that hesitation you just felt? That's actually the smartest instinct you can have in 2026. Because here's the dirty secret that AI labs don't put in their press releases: a benchmark score tells you almost nothing about whether a model is actually smart. It tells you the model is very, very good at that specific test. And those are two very different things. Today, we're pulling back the curtain on how AI performance is actually measured, why the old rules no longer apply, and what metrics you should actually be paying attention to, whether you're a developer, a business owner, or just someone trying to figure out which AI tool is worth your time. Let's get into it. Not long ago, the AI field operated on a simple assumption: if a model was the best at one major task, it was probably the best at most tasks. Training a powerful model meant feeding it massive amounts of general data, and the smartest model rose to the top across the board. That era is over. We've entered what researchers are now calling the age of post-training dominance. What does that mean in plain English? It means that after a model learns the basics of language, reasoning, and knowledge from the internet, which is what we call pre-training, companies then spend enormous resources reshaping that model for specific purposes. Think of it like this. Pre-training is like putting a student through 12 years of general education. Post-training is like sending that student to medical school, law school, or a coding bootcamp. They come out exceptional in one lane, but you wouldn't ask your cardiologist to argue your court case. Industry estimates suggest that around 80% of the computational effort for modern AI models now goes into post-training, not the foundational learning, but the specialization on top of it. This fundamentally changes how we should evaluate AI. A model that scores first on a math benchmark might be mediocre at creative writing. A model that blows past every other system on coding might embarrass itself on a logic puzzle a 10-year-old could solve. The leaderboard doesn't mean what it used to. Here's where things get uncomfortable. You know how in school, a student can score 95% on a test without actually understanding the material just by memorizing patterns from past exams? AI models can do the same thing, and they're getting very good at it. There's a concept called benchmark contamination. It happens when a model's training data includes examples from the very tests it's later scored on. The model doesn't reason through the problem, it pattern matches to something it's already seen. One fascinating example involves a category of tests designed to measure abstract reasoning. Researchers found that some models weren't actually solving the problems the way humans do. Instead, they were picking up on accidental numerical patterns embedded in how the problems were encoded. The model found a shortcut through the back door and scored well without ever engaging in genuine reasoning. That's not intelligence. That's a very sophisticated form of cheating, and the model doesn't even know it's doing it. This raises a genuinely hard question: how do you test something fairly when it has potentially already read every test ever written? Some labs have responded by creating private benchmarks tests that are never published, never leaked, never accessible during training. This is one of the most credible approaches we have right now, because it closes the contamination loophole. Results from these private evaluations can be humbling. Common sense, the kind of reasoning humans do automatically without thinking, turns out to be one of the hardest things to fake at scale. Models are improving here, but the gap between AI common sense and human common sense remains real. When a model hits roughly 80% on a common sense test benchmarked against average human performance, that sounds impressive. Until you realize the average human is scoring close to 100%, not because they're geniuses, but because that's just how humans think. Let's talk about hallucinations, because if you've been paying attention to AI for any length of time, you've heard this word thrown around a lot. But what does it actually mean for real-world use? A hallucination is when an AI confidently states something that is factually wrong. Not uncertain. Not hedged. Wrong and confident. It might cite a paper that doesn't exist. It might give you a statistic that it essentially made up. It might describe a historical event with completely fabricated details. And here's the part that should concern you: this problem has not been solved by any major model. Not by the most expensive ones. Not by the ones with the highest benchmark scores. Not by the ones with the most polished marketing. Every major model available today still hallucinates. The rate varies, the domains vary, but the phenomenon is universal. This means that for any high-stakes task, medical, legal, financial, technical, you cannot simply trust an AI's output without verification. Full stop. What's particularly tricky is that hallucinations often happen in a specific pattern. Models are most likely to fabricate when they almost know something. A model that has no idea about a topic might appropriately say, "I don't know." But a model that has partial, fuzzy knowledge about something, that model might fill in the gaps with plausible-sounding fiction. For users, the practical takeaway is this: the more confident an AI sounds, the more carefully you should verify. Counterintuitive, maybe. But important. One of the most interesting trends in AI right now is the rise of what's being called extended reasoning modes, where a model takes more time to think before answering, running through multiple steps of internal logic before producing a response. The theory makes intuitive sense. Humans solve harder problems when we slow down and think carefully rather than blurting out the first answer that comes to mind. Shouldn't the same apply to AI? The results here are genuinely mixed and sometimes disappointing. In some domains, particularly complex math, coding, and multi-step logic, extended reasoning modes do produce measurable improvements. The model catches its own mistakes, reconsiders initial assumptions, and arrives at better answers. But in other areas, the gains are surprisingly modest. Some model cards, the official technical documentation that AI companies publish, acknowledge outright that deep thinking modes may increase cost and latency without delivering proportional improvements in capability. This is an important data point for anyone making purchasing decisions about AI products. Paying more for premium thinking modes doesn't automatically buy you better results. The value depends entirely on what you're using the model for. This brings us to what I think is the most intellectually honest question in AI right now: is there such a thing as a single, objective measure of AI intelligence? The uncomfortable answer is, probably not. And here's why. Intelligence isn't one thing. It's a collection of capacities: reasoning, creativity, memory, social understanding, adaptability, judgment under uncertainty. No single test captures all of them. And any test that becomes widely used as the standard will eventually be gamed, either intentionally or accidentally, by the very systems it's supposed to evaluate. Some researchers have proposed that forecasting accuracy, how well a model predicts real-world events, might be a more objective measure. After all, you can't fake a prediction about the future. Either the event happens or it doesn't. The model's track record is the record. But even this has limitations. Forecasting can be gamed by hedging, by picking safe predictions, or by exploiting base rate knowledge without genuine insight. The honest truth is that AI labs are largely left to create and promote their own benchmarks, which creates an obvious conflict of interest. It's a bit like letting students grade their own exams. Not ideal. Until the field converges on independent, rigorously maintained, contamination-resistant evaluations administered by parties with no financial stake in the outcome, benchmark scores should be treated as marketing materials first and scientific evidence second. So if benchmark scores are unreliable, what should you pay attention to when evaluating AI tools? First, speed. For many real-world use cases, customer service, coding assistance, live document editing, response latency matters enormously. A model that's 20% smarter but 3 times slower may be a worse product for your use case. Speed is a legitimate, measurable, and highly practical metric. Second, hallucination rate in your specific domain. Don't ask, does this model hallucinate? Ask, does this model hallucinate about my subject matter? Test it yourself with questions you know the answers to. Build your own small evaluation before committing to a tool. Third, consistency. Ask the same question multiple times, in different phrasings. A model that gives you radically different answers each time is telling you something important about its reliability. Fourth, instruction following. Can the model do what you actually tell it to do? Follow formatting instructions, respect constraints, stay within scope. This sounds basic, but it's surprisingly variable across models, and it matters enormously for real workflows. Fifth, cost effectiveness. Raw capability is only meaningful relative to cost. A model that performs 10% better but costs 5x more may not serve your needs. Understand what you're actually paying per task. Here's the big picture takeaway from everything we've covered today. We are living through a genuinely remarkable moment in technological history. AI systems are improving at a pace that regularly surprises even the experts building them. But remarkable progress and reliable intelligence are not the same thing, and conflating them is one of the most consequential mistakes you can make as someone navigating this landscape. The models getting released today are impressive. Some of them are, by certain measures, approaching or matching average human performance on tasks we thought would take decades. That's real. That matters. But they also hallucinate. They game tests. They specialize in ways that make cross-domain comparisons almost meaningless. And the benchmarks we use to evaluate them are increasingly being built by the same companies that profit from high scores. The most powerful thing you can do, whether you're a developer, a business owner, or just a curious person, is to build your own evaluation framework. Test models on your actual use cases. Trust your direct experience over press releases. And maintain healthy skepticism toward any claim that a single number tells you everything you need to know. Because in the end, the question was never, which model scores highest. The question was always, which model actually helps you do what you're trying to do. Those are very different questions. And knowing the difference puts you miles ahead of most people. If this gave you a new way to think about AI performance, consider subscribing. We break down these topics in plain language every week. And drop a comment. What's the AI benchmark you would design if you were in charge? I'm genuinely curious. See you in the next one.